This PowerPoint's going to get into chemical reactions, the rate of reactions, and how energy is either needed for some reactions, or how it's either kind of emits energy or absorbs energy from its surroundings. And so look at, during a chemical reaction, energy is used to break bonds. Energy is released in the form when new bonds are formed. All right, and so we'll kind of get into this different types. So like, for example, like a dynamic explosion. That's an example of a rapid chemical reaction. Chemical reactions most proceed more slowly than a dynamite explosion, but they all release energy or absorb energy. Right? So all chemical reactions are at least absorbing or emitting energy. And energy can be in the form of any of the following there that's listed: heat, light, sound, electricity, and the breaking of bonds, or once again, the making of bonds, that's the source of the energy. When bonds break, energy is released. When bonds come together, when new bonds form, when bonds break, energy is released. When new bonds form, energy can be released or once again absorbed. Energy is required. Chemical reactions, some chemical bonds and reactants are broken, which requires energy. Bond formation, bonds produce new bonds. Products produced. New bonds must form and release energy. All right, I'm going to get into all this in a sec. All right, so there's types of chemical bonds. There's an exergonic. All right, when you see that exergonic, it's going to be something with like exothermic. Think of energy. Zoom in here. Energy is exiting. Think exergonic, exiting. It's leaving. It's being released into the surrounding environment. All right, so an exergonic reaction is when energy is exiting. All right, like so, for example, like these down here, fireworks. When you break a glow stick, there's less energy is required to break the original bonds than is released when new bonds form. So light, heat can be given off. More specifically, when heat is given off, you're also going to have to know this. Exothermic, same thing, exo, and then thermal. Once again, that therm right there, thermo, heat. All right, so thermo, think heat. That's specific to heat. So exothermic, thermal energy, heat. Heat is exiting. Energy is given off in the form of heat. And you'll have to know that. Primary energy is given off in the form of heat. Now, an exergonic, all exothermic are a type of exergonic, but you can have exergonic reactions that are not exothermic, meaning because energy is giving off in some other way. Sound is being produced or light is being produced. It doesn't have to be heat in an exergonic reaction, but an exothermic reaction, it is heat. It's specific to heat. And so that's the burning of wood, dynamite exploding, etc. Those are exothermic reaction. Once again, and it releases energy to the surrounding environment. I tipped over in my chair there. That went bad. Energy released by making new bonds outweighs the energy required to break the old bonds. And so a formula would look something like that. We have energy is being released. And then the other type is when more energy can get taken in. All right, and in, it's spelled different, but you can think of it like in, and N equals in. Trying to help you remember here. Don't judge me. Endothermic reactions, or endergonic reactions, excuse me, that is when chemical reaction requires more energy to break bonds than is released when new ones are formed. Energy absorbed, it can be in the form of light, heat, electricity, whatever. Heat must be added. And so when an endergonic reaction, energy is actually absorbed from its surrounding environment. Energy is absorbed because it needs requires more energy to break bonds. Here, let me highlight that real quick. Chemical requires more energy to break bonds than is released when new ones are formed. All right, and then obviously endothermic, once again, heat is absorbed, specifically heat is absorbed. Energy is needed in the form of heat. And we'll look at these. We'll look at a couple examples of these in class. We'll do like a chemical reaction involving heat being released, and we'll do one where heat is being absorbed. It's taken from the surrounding environment, taken from the air, because it needs more heat. Reaction that absorbs energy. Once again, it's a reaction that absorbs energy. So an endothermic, it's taken in. Endothermic is taken in. Energy required to break old bonds outweighs energy released by making new bonds. And there's a couple other terms that I want us to know. There's a catalyst. A catalyst, I like those sound effects. Catalyst is a substance that speeds up chemical reaction without permanently being changed itself. The mass of the product that is formed remains the same, but it will form more rapidly. All right, so the mass of the product, it doesn't change the outcome of the product. It just helps speed the process up. You can think of like, what's an example I'm trying to think of? Oh, you know, we just got done with winter. You know, when they say salt can rust a car door. Well, that's not entirely true, because what happens, you know, when salt gets on cars, what happens is that the iron, the iron oxidizes. The iron reacts with the oxygen, and so either in the water or in the air. And so what happens then is it becomes iron oxide, which is rust. All right, but what salt does is salt does act as a catalyst. It can help speed that process up. And so while salt itself isn't necessarily what causes it to rust, it's the oxygen from the water, from the air. It is a catalyst. It will help speed up a reaction. An inhibitor is used to slow down a chemical reaction. Once again, they do not change the amount of product produced. They only change the rate of production. All right, and inhibitors can be used. You know, sometimes it's beneficial to speed up a reaction. You know, like especially in like business, if you're whatever it is, if you're trying to get something done more quickly. But it's also, you know, inhibitors are used on products where they want to slow down a chemical reaction. Like for example, like BHT, like food preservatives. You know, and those are a type of inhibitors because what they do, because food spoilage is a chemical reaction, and so what they do is they use inhibitors on those different food preservatives to keep food so it stays fresher longer. And so if you know, if you're a farmer and you want your food to stay fresh longer to get to, you know, by the time it gets shipped and packed in the stores, you'd put these inhibitors on them. You know, BHT, for example, would be one of them. But what that does is that slows down the process of food spoiling. Right, and so it's a chemical used to slow down. It's an inhibitor. It doesn't alter the substance in any way. It just slows down that reaction. All right, so that would be like an example of an inhibitor, something that slows down a reaction. And so that's those are the basic parts. Once again, we'll get more into the rate of reaction, but a few things that you got to know. Once again, a couple terms there: catalyst and inhibitors. Catalyst speeds up, and inhibitor slows down. You're gonna have to know endothermic. Sorry, this is really glitchy. Endothermic and endergonic reactions. Once again, think of endo, taken in, energy is absorbed. Exo, it's leaving. Exothermic, it is leaving. Energy is being released during this process. So energy is given off. If it's exothermic, it's in the form of heat. If it's exergonic, could be heat, could be light, could be sound, could be whatever. And so, but those are the main points from this that I wanted us to get.